Okay, hello everybody. Apologize for taking so long to add to this series. This time we're going to talk about how to arrive at some of the voltages you need and some tricks you can play with transformers and power supplies to get whatever voltage you want, and a little bit of math thrown in to help you figure things out. Here we have just a standard common full wave bridge rectifier hooked up to a 12 volt AC transformer, 120 volt in. The voltage you're going to get out when you're trying to figure this, always figure your AC voltage times 1.414. That'll give you pretty close when you're figuring out what size of capacitor you need, like what voltage. On this one, a 20 volt unit would be available, but you see at 17 volts, I would say that would be a little too close to 17 to make that capacitor last a long time. The next standard value up would be 25 volts, and that would be my choice. I would use a 25 volt unit in for C1. Okay, next, this is a voltage doubler. We can get a little more voltage out of that 12 volt transformer. So here, take our 12 volts, multiply it times 2.828. That'll give our voltage output. Here we have approximately 33.9 volts. Now another thing comes into play here. We have another capacitor, and you would have to pay attention to the rating of that. And researching to make sure I was as accurate as possible, over in the handbooks, they call for a 4 times higher rating than the 12 volts for this C1. Now, a long time in my building stuff, I have not done that, and this may have been some of the reasons for maybe a premature failure to this type of cap in this position, because I usually would go 3 times. But in essence, what's going on here, for each half cycle, this capacitor is in the circuit essentially backwards. And that's what they're talking about, is why they have to have the more higher voltage rating. Because this is a voltage doubler. On one half cycle, it's rectifying one direction. The other half cycle, it supplies the opposite, the negative. So, and this capacitor has to work both of those half cycles. So the voltage rating for both of these would be a 50 volt unit, would be safe. Okay, now something you can do with transformers, if you don't have the right voltage transformer, that maybe you have a couple of them or more, you can do this. You hook the primaries parallel, and it wouldn't really matter that you can't find the start or finish winding, even if they're identical. What you would do is you'd hook them up in series, then measure the voltage all the way across. Depending on how matched these two transformers are, if it's hooked up wrong, you might see either anywhere from 0 to maybe 1 or 2 volts, and you'd know that something's wrong. So just flip one of the windings, and that'll put them in series to where the voltage will add. And this is just another full wave bridge, and we come out with our same voltage of 33.9 volts figured out there. And we're still using the 1.414 with our 24 volts for that voltage. Okay, for like a simple, let's say we needed a 5 volt supply, and we were going to tie downstream of this right here maybe a 7805 voltage regulator, a three terminal voltage regulator called a 7805. This would be a typical circuit. This would be a 12 volt center tap transformer. It's in full wave bridge because we're using the center tap and grounding it, so we're not getting 12 volts. We're just getting each half cycle, each half of the 6. So we actually come out to about 8.5 volts if you use that figured out. C1, I didn't put the value on here, but if you was going to use it for a, like I say, for a 5 volt supply, you might want to go 1000 microfarad at say 15 volts for that. Would probably be a good rating. 16 volts might be a common one to get a hold of. Okay, if you're needing a supply to supply voltage for relays, you could use this. This would be 12 or 24 volt. In my stuff, I prefer 24 because I use 24 volt relays. You don't need a whole lot of filtering, but 100 microfarad works pretty good. The resistor is arbitrary. I start out with about 100 ohm. Most of the relays are pretty low current draw, so this maybe just barely gets warm when the relays are activated. You'd want to check that out, check your current, but you're going to have about 34 volts out of this circuit if you got 24 in. So be aware of that, and that's fine for a transistor key in a relay that works at that voltage just fine. This voltage, this resistor will drop it a little bit with the current being drawn across there, and it'll come back to probably 28 volts on that relay, which is just fine for a 24 volt relay. Alright, if you were wanting a small, a QRP transmitter, where you're using like a 6AQ5, 6BQ5, or a little 6V6 output tube, and you needed some lower voltage, a lot of times it's hard to find transformers to get that voltage. Here's a trick you can play. This is an industrial transformer. It has two 115 volt primaries, and what this is for is so they can hook them in series and run this transformer in say 230 volt, or in more common you hear of 120 or 240, but there still would be the same transformer. This is a part that it's available at all electronics for $19.50. This is the part number. It's made by Triad, and this is Triad's part number is what they show. And this would work really slick. This would give you about 230 volts output. Now the trick here is a little bit different going on. Not just a voltage doubler. This is a voltage tripler. Takes 12 volts, triples it to about 53 volts. And the one other trick here is the one winding from the 115 is in a full wave bridge, and you can stack it by hooking the negative of that circuit to the positive of this one, and it'll add from ground to the B plus, you'll have the 230 volts right in there. And it's isolated from your 115 volt winding. This won't supply a whole lot of current, but with this transformer it would be very safe to run that. You'd probably get 10-15 watts out of the circuit real easy without overheating the transformer. And that's, like I said, that's a transformer that's available right now. It's a fairly decent price, fairly simple little circuit. All of these caps here are 220 microfarad, I should mention, and 200 volt on all of these, even that one. The diodes are 1N 4007s, which is a 1 kV, 2.5 amp diode. Alright, here's another example of another transformer available from Surplus Center in Nebraska. This one runs you about $8.99, and here you'd take two transformers. They're 120 volt to 24 volt. So you'd take the two of them, hook them back to back. In other words, you'd hook the 24 volt windings together, 120 volt in on one, will give you 120 volts AC out on the other transformer, but it's isolated from your mains, so it's safe. Plus, if you use the center tap and ground, you're going to get your 12 volt voltage for some tube filaments. So you're kind of getting both. You're getting your B plus transformer and you're getting your filament transformer all from the same supply. Just use 2 transformers. Again, the caps are 220 microfarad, 200 volt, and the diodes are the 1N 4007s. Bleeder resistors are 220K. This is what the one supply would measure, 170 volts across this, what you're going to get there. And you're going to add it to the 68 volts. And this simply is just a little voltage doubler circuit here on the 24. Just a simple voltage doubler. And that the two are combined or stacked so that between ground and the top B plus you get 237 volts. Okay. Now, voltage dividing. Let's say we don't need all that voltage, we want some lower voltage. So here'd be a way you could get 5 volts from a 12 volt source. And this is the math behind it. Here, RT, we're talking about the total of these 2 resistors, R1 and R2. They're 10,300 ohms, or 10.3K. Current divided across these is figured current equals the voltage divided by the resistance. When we do that, 12 volts divided by the 10,300 ohms, we come up with 1.16 milliamps. Then we use that figure, voltage dropped across the resistor equals the current times the resistance. So here we have the current dropped across the first resistor, a 5600 ohm resistor. Comes out, the voltage drop is 6.524 volts. That's the drop across there. The last one, same current. You drop out the other 5.4755 volts. So at this point, from ground to here, you would have 5.4 volts, just a little over, almost 5.5 volts. But again, this current is real low. We're at 1.16 milliamps. So if you needed a little more, or if you wanted to be a little accurate, let's see, yeah, if you want to go the other way, that was a little bit too hot. You want to come up under that, just under 5 volts, just simply tweaking one resistor, drop a little more voltage, your current is going to be lower, and you come out to 4.9 volts. And that's the math behind it there. Okay, now you need a little more current. So here's a quarter of an amp, or 250 milliamps. And see, this 5 volts here, you'd be able to draw a little more current now. Maybe to light up some LEDs or something. But this is the math that you'd use to figure your current drop, voltage drop rather, and the current through the circuit. Okay, another way to drop voltage is with using a tube. This particular instance, it's an OA2 voltage regulator tube, gas regulator. There's no filament. It just has like I think it's argon gas in these. And with a 300 volt power supply and a 10K resistor, this tube will regulate and hold at around 150 volts output. Not a whole lot of current, but you'd use that to run like an oscillator that you wanted to feed from a stable voltage. And here's the math behind that. And your actual voltage draw, or your wattage drawn through the resistor, you'd want to keep note of that. You wouldn't want to use a half watt resistor here. you're going to have about 2¼ watts, so the closest unit to that would be a 5-watt resistor. Okay, now, a lot of times you might not have a voltage regulator, but I'll bet you didn't know that a diode could be used, a simple diode could be used to drop voltage. Standard 1N 4007 or 4004, 4001, any of those diodes will drop about 0.7 of a volt, 0.7 volts per diode. So if you had 12 volts coming in, you could drop to 5 volts. A little bit of a load here, we'll keep that at 5. It won't, if this wasn't here, well, this is unloaded, say you had a cap here or something, this would rise to the 12 volts with no load being drawn across it. So with a little bit of a load there, you'd have 5 volts for a low current. Now another place this could be used, say you had a little amplifier, you wanted to provide some cathode bias. The same idea, you'd use as many diodes as you needed at 0.7 volts per diode will give you a bias on your cathode. This is a milliamp meter thrown in. If you was going to monitor the current in the tube, this is where you'd put the current meter. And that's about it. If you have any questions and you want any of those schematics, they're all in JPEG format. So if you shoot me an email or a self-addressed stamped envelope, however you want to do it, or message me somehow, I can attach those JPEGs to an email and send them to you and answer any other questions you have. So thank you, have fun experimenting, and we'll see you on the next video.